Hello, my name is Ryan Ramito, and today I'm going to be walking you through experiment 6, which was chemical equilibrium, and I'm going to walk you through parts D and parts E of this experiment. Now, to begin, you want to determine what was this experiment all about, which was to determine the changes in concentration of the reactants and the products and how they affect the actual chemical equilibrium. Now, I'd like to begin starting with part D, which is COH2O6 2 plus aqueous plus 4Cl minus reacts with CO or becomes COCl4 2 plus aqueous plus 6H2O liquid. Now, to begin this, you first want to determine what are the colors of these ions, and the ion of COH2O6 becomes a pink, or started out as a pink color. Now, the color of the next one you want to look at is COCl4 2 plus, which was a blue solution. Now, when in order to determine how or which way the chemical equilibrium shifts, you want to add HCl. Now, when HCl is added to this solution, it becomes a purple solution because of an increase in temperature of Cl, meaning that when these two react, an increase of the temperature would cause this equilibrium to shift to the right because more heat is being added, or shift to the right, which is the product side, and it would turn to a more darker blue. Now, when you add heat to this solution with the HCl, the heat added causes the shift right again, making the solution back to a darker blue, which means that the more reactants you add, the darker the product is going to get, which would help the next statement of when the solution loses that heat, it actually goes back to a light pink, causing a shift left of the equilibrium, which would make this a endothermic reaction because the heat causes a darker color. Now, part E, you want to look at the equation Fe3 plus aqueous plus C or SCN minus aqueous reacts and becomes FeSCN2 plus aqueous. Now you want to find the colors of all of these ions, and Fe3 plus ion was clear and colorless. So was SCN minus was also clear and colorless, and but FeSCN2 plus was actually a dark red. Now, in order to find out what the shift is here, you want to add at KSCN and FeNO33, and when those mixed, it turned to a dark red, which caused a shift to the right, which explains the clear and colorless solutions to turn into a dark red. Now, since those turned into a dark red, proves the color change. So now you want to add heat. When heat is added, it became a light orange. So when the increase in heat caused it to shift to the left towards the reactant side, because the dark red color became a lighter orange color. This is because when the heat, or this would cause a shift away from the products to the reactants, which makes this reaction an exothermic reaction, unlike the last one. Now, sorry. Now, when FeNO3 and KCN were added again, it turned darker, since there's an increase in Fe3 plus, it shifted to the right. When more KCN was added, it turned darker again, which was an increase in SCN, and that also shifted back to the right. Now, when AgNO3 was added, precipitate formed. The precipitate was formed since it was white and cloudy in the tube. And it was white and cloudy in the tube because there ended up not being no solid. It's all aqueous, which causes it to be that cloudy solution. Since that was the compound that was formed, the heavy shift would go to the left since the contents of the SCN minus were decreased, which became... So when the SCN decreases, it would shift back to the left, which would recause this clear and colorless solution to return from this cloudy white substance when the AgNO3 was reacted, would cause the shift left back into the reaction. Thank you.